I'm baking a cake for my friend's birthday. But while I go through the ingredients, I can't stop thinking about proteins. Why? Well, like cakes, proteins have a very specific recipe. What do you think of when I say protein? You might think of fish.
Or of a protein shake?
In biology, a protein is an organic compound that is made up of folded polypeptide chains. That's complicated. Maybe a different visual will help. These are models of a protein.
I made this out of candy.
The primary structure is an amino acid sequence. Each amino acid has a unique group called an R group. The amino acids are bonded by peptide bonds. The secondary structures are an alpha helix and a beta pleated sheet. Hydrogen bonds form between amino acids to stabilize the structure. The R groups stick out of the helix and sheet. The beta sheet is made up of 2 or more adjacent polypeptide chains. In the tertiary structure, interactions in the R groups of both the alpha helix and the beta sheet cause many polypeptide chains to fold. One interaction, as shown in this model, has like R groups clumping together. Other interactions include the clumping of R groups with opposite charges, or the clumping of R groups with the shared like or dislike of water. Finally, we have the quaternary structure, where multiple folded polypeptide chains come together. Still confused? Think of it like a cake. All 4 structures mix together to form the final product. The primary structure is like the ingredients. The secondary structure is like the folding of the wet ingredients in one bowl and the dry ingredients in another.
The tertiary structure is like the folding of the wet ingredients and dry ingredients together, then putting the mixture in the pan and baking in the oven. And the quaternary structure? Layer cake! Yum!
But just like in baking, changing an ingredient in a protein can have disastrous results. This time I used garlic powder instead of baking powder. Ugh, that'll teach me. For example, hemoglobin is a protein in red blood cells. When hemoglobin is sound, normal red blood cells are flexible and can fold to squeeze through blood vessels. But when the amino acid glutamine is replaced with valine, the cell becomes sickle-shaped instead. Abnormal hemoglobin does not carry oxygen well and deforms the cell to give it sharp edges. This leads to a condition called sickle cell anemia. These sharp edges poke holes in blood vessels and damage organs. I hope my friend likes this cake, and I hope understanding protein structure is a piece of cake for you too.